Today we're going to be looking at solving algebraic equations and inequalities. And so first things first, we need to define inverse operations, which are operations that undo one another. So our first one are addition and subtraction, and then multiplication undoes division, and squaring undoes taking the square root. So our entire goal in this lesson is to isolate the variable. That might also be considered the entire goal for algebra. We're always solving for a variable. So first things first, let's look at one-step equations and inequalities. Number one here, it's going to say solve, and then letter A, we'll have x minus 4 equals 19. And in order to get x by itself, we have to get rid of this 4, so the opposite of minus 4 is plus 4. We always do it on both sides of the equation to keep it balanced. That equal sign is like a scale. So we get x equals 23, and now we're going to check it. We're going to plug 23 into this original equation where we see x, we get 19 equals 19. So we know we've done it correctly. Letter B, we have 5 plus y equals 29. We want to get rid of that 5, so we're going to subtract it because 5 minus 5 turns into 0. And we get y equals 24. Now let's check it. We have 5 plus y equals 29, plug in 24 for y, and we get 29 equals 29, check. Alright, for letter C here, we're going to be looking at one that involves multiplication. So we have 3m equals 12. We know that if a number is written right next to a variable, they're multiplied, so we have to do the opposite multiplication. We divide both sides by 3. We get m equals 4. Now let's look at this check. 3m equals 12, 3 times 4, we get 12 equals 12, check. Letter D, we're going to have b divided by 4 equals 9. Well, the opposite of divided by 4 is going to be times 4, so we'll do that to both sides of the equation. We get b equals 9 times 4 is 36. Now we'll check it. 36 divided by 4, we get 9 equals 9, check. Letter E, we're going to bring back some fractions. We have 2/3 x equals 5. That 2/3 and the x are multiplied, so the opposite is to divide both sides by 2/3. Remember, when we divide by a fraction, what we do is we turn that 5 into a fraction, 5 over 1. We flip the 2/3 to make it 3 over 2, and then we multiply those. So we get 15 over 2. Could be left as 7.5, 7.5. You could possibly leave as 15 over 2. I think I'm going to use 15 over 2 in my check, just because it's going to make our simplifying process a little bit smoother here. So there's the original equation. There's 15 over 2. Multiply those two, we get 30 over 6, which we know 30 over 6 is 5. 5 equals 5. Check. Letter F, we have x plus 2.3 is less than 13. We're going to subtract 2.3 on both sides. 13 minus 2.3 is 10.7, so x is less than 10.7. With an inequality, when we have that less than or greater than, whatever your symbol is, it just means that any number less than, in this case, 10.7, is a solution to this equation. So to check it, I'm just going to plug in 10. That's less than 10.7. Alright, so those are one-step equations. They only took one step to solve them. But now we're going to look at multi-step equations. So, little note here, and this is true most of the time. In order to solve, we use order of operations backwards. I'm going to put that backwards in quotes because, like I said, it's true most of the time. So here I'm writing out the order of operations steps, but I'm writing them out backwards. So we would work on addition and subtraction first, division and multiplication second, exponents, roots, and parentheses third. So number 2 here, solve letter A. It's going to say 3x plus 4 equals 64. Subtract 4 on both sides, we get 3x equals 60. Divide both sides by 3, and we get x equals 20. Now remember that if we had divided by 3 first, we would have also had to divide the 4 by 3, and we probably don't want to deal with 4/3 as a fraction, so it's easier to just get rid of the 4 first and then divide by 3 second. There's a check there, we get 64 equals 64, so we know that 20 is our solution for x. Letter B, we have -3 plus 15x equals 17. Add 3 on both sides. 15x equals 20. Divide by 15 and reduce that where x equals 4/3. So in our check here, we've got -3 plus 15 times 4/3 equals 17. We get 60 over 3, which is 20. -3 plus 20, 17 equals 17. Check. For letter C here, we have 3 times x minus 9 equals 15. We're going to look at two different ways to solve this. Both are equal algebraically. Just kind of depends on which one you think is faster, which one you like doing better or more comfortable doing. The first one is if I'm going to distribute that 3. It turns it into 3x minus 27 equals 15. Add 27 on both sides, we get 3x equals 42. Divide by 3, and we get x equals 14. Option number 1. Option number 2, I'm going to take that original equation, and I'm going to divide the 3 out first. So we get x minus 9 equals 5. Then add 9 on both sides, and we get x equals 14. Same answer for both of them, so it's up to you which one you are more comfortable with or you feel is easier in that situation. I'm going to plug 14 in here for x and show that we get 15 equals 15. Check. Now, when we have variables on both sides of the equal sign, we have to use the inverse operations to move the variables to one side and the numbers to the other side, and then we can solve just like a normal equation. So let's look at examples where we've got a bit more of an in-depth equation here. We've got 2x plus 7 equals x minus 14. I'm going to subtract the x from the left over to the right there. So 2x minus x is just 1x. So we get x plus 7 equals negative 14. Subtract 7 on both sides, we get x equals negative 21. Now it's important to notice here when I'm showing my work that notice all my equal signs are lining up. My work is very neat. Try and keep it all organized. That way, if we do make simple mistakes, we can go back and find them easily and we can follow our own work. Here we are plugging negative 21 in to check, and we get negative 35 equals negative 35. Check. All right, for letter B, we have 6 plus 2m equals negative 3m minus 14. And what I'm going to do first is I'm going to add that 3m on both sides. I could subtract the 2m, but then I'd have a negative 5. And sometimes it's nice to avoid negatives in our problems if we can. Although then here I have to subtract the 6, so I do end up getting negative 20. Divide by 5, we get m equals negative 4. And we'll check that. 6 plus 2 times negative 4 equals negative 3 times negative 4 minus 14. Negative 2 equals negative 2. Check. All right, letter C. We have negative 4 times x plus 9 equals 8x minus 24. I'm going to distribute this negative 4 here. Once again, I could have divided it, but then I'd be dividing the 8x and the 24 by 4. So in this case, we're just going to distribute it. We get negative 4x minus 36 equals 8x minus 24. I'm going to add 4x on both sides. Negative 36 equals 12x minus 24. Add 24 on both sides. Notice here I'm putting my numbers on one side of the equal sign and my variables on the other. We end up getting negative 12 equals 12x divided by 12. We get x equals negative 1. Let's plug it in. We get negative 32 equals negative 32. Check. All right, last example here, letter D. We have x plus 7 divided by 3 equals 9x. And I meant to make that a negative x. We'll go back and change that here in a minute. We're going to multiply by 3 on both sides. Here's where I notice that it should be a negative x. There we go. So now we're going to add x on both sides. I wanted to give us a number that's nice and divisible by 7, so the goal was 28. There we got 28, with the original problem being negative x plus 7 divided by 3 equals 9x. And we get x equals 1/4. Let's plug it back in. Negative 1/4 plus 7 is going to be 6 3/4. Also equivalent to 27 over 4. Then when we divide by 3, we're actually multiplying by 1/3. You can see my confusion there. I did 3 over 1, should be 1/3. Whoops. So then when I multiply this by 1/3, I get 27 over 12. And 9 over 4 equals 9 over 4. Check.